All right. Hey, hi guys. Good evening, everyone. Thanks for joining in. I'll just wait for everyone to, join, and then we'll get started with this masterclass that we have today. How to leverage, upgrade your data analysis techniques with artificial intelligence. Thank you so much, everyone, for joining in. Before we get started, guys, just give me some, understanding about you guys. Tell me those who are working professionals. Please just write in the message, working professional, or those who are students, just write students. Let me see what's the split of the people who has joined this master class. Okay, working professional, student, fresher, student, student. I can see bunch of students here. All right, all right. Okay, so guys, are you excited for this master class, for this webinar? I can see there is a couple of working professionals and a lot of students here. I'll just wait till more people join. I can see still some people joining. So I'll just, start in a bit. So give me a thumbs up if you are excited for this opportunity. So at the end of the session, we will also talk about, you know, um, how do we, yeah, there's one thumbs up. That's great. Let me coordinate with the team. Okay, okay, I can see a lot of thumbs up. Okay, that's it. All right, I think we are on time. We can get started with this. Let me just have some confirmation with the team and then we can get started. Thank you so much. You guys are going to get a lot of understanding of artificial intelligence and how to utilize that into analysis. And as I can see, a lot of people who are, freshers, who are students, and there's a couple of people who are, working professionals. So I'll try to curate the topic in such a way that it maximizes the understandability of a lot of different peoples, not just very few people in this. Now, um, let me just help you understand. Is there anyone like who knows the full-fledged data analysis? Like, if you know, you can write yes. If you don't know full-fledged data analysis, just write no. That will help me to curate the topic that I have, and that will also help you guys to understand in much better way, right? Because if you already know, I may explain in a different pattern. If you don't know, maybe I will take a different way of explaining the things, right? So I can see a lot of no here. That's great. No issues. There is no shame. There is no harm in this. You guys are here to learn and understand. And I just want to utilize maximize the timing that we have here. So if you guys already know something, maybe I can curate on top of that. I don't want to, just keep going through the things that you already know. If you guys don't know, maybe going a little extra doesn't make sense. Maybe I can cover the fundamentals in that case, and that is very crucial thing in here. All right. Okay, so let's get started. Let me start sharing my screen. And as I said, in this session today, I'm going to talk about the artificial intelligence. I'm going to talk about how can you leverage the artificial intelligence in your data analysis task. Let me share my screen and let me know if you guys can see that. 1 second. Let me have some section controls here. Okay. Okay, let me share my screen now. Perfect. I hope you guys can see the screen. Just give me something in the chat if you can. Yes, visible. That's great. Thank you so much, everyone, for joining this session. Let's start with the topic that we all are gathered over here to understand and to learn about, and that is to how can we upgrade your data analysis techniques with artificial intelligence. See, in today's world, AI can do a lot of different things, right? AI can do a lot of different things, and this is in this session we are going to see how can you make the artificial intelligence help your analysis techniques. Now, before actually understanding and seeing what exactly how exactly AI can help that, I'll also tell you what is artificial intelligence and how that gets divided into a different bunch of topics, such as machine learning, such as uh, uh, you know data-driven machine learning, AGI, artificial general intelligence, right? What's the different versions of Chat GPT means, or not just Chat GPT? We have a bunch of other AI tools, right? So we are going to categorize them. What does data scientist means? What does data analysis means? What does machine learning engineer means? Right? What does the data engineer means? So all of these techniques we are going to go through, right? You are going to understand. It is going to not just help you these roles, job roles very well, but also help you decide which one you want to go through. Right? It's not just the data analysis, but if you combine your data analysis with artificial intelligence, you can be data engineer, you can be data scientist, you can be machine learning engineer, and a lot of different scope opens for you. Now, let's explore the impact on the analysis and learn the practical tools and discover the implementation strategies and practice hands-on applications. Right. In this session, I'm going to tell you about what are the AI tools that you can utilize to help your learning better and help your analytics analysis better. Now, let's understand the data analysis evolution. Right. In 1990s, people used to have like manual spreadsheets, like before Microsoft, when Microsoft actually built Excel and all. Before that, there were manual spreadsheets. People used to use papers and pens, and they were used to actually write on the papers, and they were used to make the spreadsheet over there. So it was time consuming. There was a lot of chances of having the errors, and you cannot process a lot of data with the help of that manual, uh, you know, uh, spreadsheets. Now, after that, I like before even before that, there were a few, I would say, tools. After that, the Microsoft came, and there were some spreadsheets like Excel and some other tools. But after that, When these tools became normalized, right, in 2000s, when these tools became normalized, see, the success of the tools depends on how many people uses that, right? If you have built a great product, but nobody is using, that doesn't have any utility in there. Like that project cannot be continued for a long time, and ultimately that has to shut, even if doesn't mean that if it is a great product or not. So now in 2000s, we have business intelligence, we have dashboarding, reporting, and automations due to the rich software experience that Microsoft built. Now Microsoft had the total ecosystem of softwares, business intelligence tools, BI tools, and all of that. Um, and then we had reporting basics. So basically, report, you can create reports based on the Excel data that you have, based on the spreadsheets that you have, and you can also do the small, basic automation based on the software building, right? And then after that, then came the big data. Now, when the internet started rolling out, we had a huge data, right? We started creating huge amount of data. Like every person having a mobile phone, doing anything, even if it's not doing nothing, it's just moving around few places to the other. They are generating the data. They are GPS data where they go day by day. They took the pictures, they posted to the social media. Now suddenly the data flooded all over the internet, right? So then the big data processing and cloud platforms came into the reality, and this is when a lot of companies made their big data processing units. Now, what is big data and how is it different from the normal data processing or normal data analysis? If you analyze a certain extent of a data, right, that is not big enough. Let's say you are analyzing, let's say, the population of a state, right? And that too does not contain a lot of information, right? But versus you're analyzing the population of all over the world, and that has huge amount of demographic information, not just that. Along with that, you have a huge amount of other information. There's a lot of different features, a lot of different columns. Then that becomes a big data. Now, processing billions of rows in just matter of seconds is not possible until unless you have some supercomputers, right? So they implemented some strategy to actually, you know, to actually transform the real-time data processing and to actually divide the data into chunks and then process them and then sum them together. And also came some advanced visualization along with that. Now, there were, bunch of cloud platforms such as initially AWS and Azure. They came into the market and they really disrupted it with their cloud big data processing units. Now, you cannot just process the previous data, but you can also process the real time data as well, along with the advanced visualization. Now, in 2020, if you can see after 2021, especially, uh, the automation insights, like the AI came into the place when the first AI chat GPT was launched. It was revolutionary, right? Even though if you see on today's context, that will seem like nothing, right? But today, the predictive analytics, the capability that today's AI systems have, it was nothing when it was first launched. But even then, it was a big deal because there was something that was generating the text on its own, right? There is a huge difference between artificial intelligence that we used to do before versus this generative AI that came into the market. Generative AI, it's kind of that generates its own outputs depending upon what it has been trained and what it has asked to do. Now you can automate the insights, you can automate the reports, you can automate the predictive analysis, right? You can do the predictive analysis with the help of artificial intelligence. You can do natural language processing. You can write codes with that. You can analyze. You can create images with that, right? You can create videos, analyze the data in the spreadsheets. I'll come to that as well. How you can do that. Now, these are capabilities that came after 2020. So this has been the evolution of data analysis or the history of data analysis. Now, why the artificial intelligence can change almost anything that you can think of. See, there is a huge amount of data challenge if you see, right? There's a huge volume of data that is there. There's a huge volume of data. Now, if you see the huge volume and the speed and the complexity that the data has been being generated, right? You can see since India started using 4G networks with Geo, people started generating like immense amount of data because India has a huge amount of huge population. And when everyone got mobile phone and data got so cheaper, they started generating a huge amount of data, right? Even though we have a huge user base, right? Getting money out of our pocket is very complex. So companies try to analyze the pattern and try and tend to see where they can make a change in here. So people are generating huge amount of data, huge volume at a very large speed and a very complex amount of data that demands accuracy. So you are demanding volume, sheer volume processing data units, speed is very complex, is very essential. Complexity of solving the questions, solving the problems is very essential, and accuracy is also. Now, AI is the solution here in that case. AI can process a huge amount of data very fast as compared to humans, right? It can recognize patterns. It can do scalable jobs. It can do repeated jobs, and it can scale that to a very large extent, right? And you can not just do that, you can also do the predictive modeling as well, right? Now, what are the business impacts if you do this? So you will notice not just 60 to 80, this is the moderate figure, but even see, you can do 100% increment in your work. You can increase your profitability by 100%. You can increase your productivity by 100%, right? You can do a more faster analysis, right? You can write very fast codes, uh, and you can also increase or decrease the. You can also increase the accuracy or decrease the chances of being faulty. And as along with that, you will have to be the continuous learner. If you fail to do so, maybe you will lag behind in the market, right? So now we are going to see how do we actually target this. See, what are the core AI techniques? Before I actually go into this machine learning, deep learning, and natural language processing, I will tell you a little bit more about artificial intelligence. So I hope you can see my other screen. So here I'm talking about. So before I actually go ahead into and understand you guys into what is artificial intelligence and all, can I get some example from you guys? Just give me some example. What is artificial intelligence according to you people? Can anyone just write me in the chat section? That will be more than enough. I mean, I'm not expecting the exact answer, the correct answer maybe. I just want to know what is your understanding of artificial intelligence. What do you think is artificial intelligence? What is AI according to you? I can't see anything in the chat. Anyone, guys, please. As you can see in the screen itself, it's a tool which is used to give the information as per the prompt given. I think you are more likely talking about the generative AI, not the conventional AI. AI cannot just give the information, but it can do a lot of different other things as well. And the example that you have given, it's a very narrow field. That is also an artificial intelligence. That's not wrong. But artificial intelligence is not just that what you told. It's a very vast thing. Okay. Madesh is artificial intelligence is the type of intelligence through which machine can think and act like a human from the mistakes of like humans and learn from the mistakes of. That is actually a good example. Perform tasks without human intervention. That is also a good example. But actually, the definition of AI lies within the name itself, right? If you see the name of artificial intelligence, what's that? AI, right? If you see the name of artificial intelligence, the first is artificial, the second is intelligence. If you try to define artificial and intelligence, you will find like it's nothing but the same thing, right? Something which is artificial and if it has intelligence, that is artificial intelligence. But let's define what is artificial and what is intelligence first. So artificial is something that is not natural, that is made by humans. And intelligence is ability to think, ability to reason, ability to take decisions. That is called intelligence. If something like humans, we do have ability to think, ability to reason, connect the dots, right? Ability to take decisions, right? Any other species, if you see a dog, a cat, right? A mouse, right? Even a fly, even worms, viruses, these are nothing but the biological things. We have not made them, but they are intelligent. They are good to take decisions, right? They might not have ability to think, maybe reason, but they can take decisions for themselves, right? Like viruses I'm talking about. But definitely like cats, mouse, dogs, every one of them can think, reason, and take decisions. Now coming back to intelligence. So anything which is artificial, which is not natural, which is made by humans, and if it has ability to think, reason, take decisions, we can say that that is an artificial intelligence. Now, AI has two core parts of it. Like, see, AI you can think of it as an umbrella, like as a superset, and within that, machine learning is a subset of artificial intelligence, right? Machine learning is a subset of artificial intelligence, and deep learning is basically another subset of machine learning. So if you just talk about deep learning is just another subset of machine learning. The difference between ML and AI is basically see anything if you can code that to make decisions, to take decisions, so that can think of as an artificial intelligence. There are various types of AIs as well, right? You can think of an AI, um, an artificial intelligence that can you know do the things based on that is coded, right? There are various types of that is narrow AI, um, AGI, or super AI. Narrow AI is basically artificial intelligence that operates on a very narrow field, right? Such as, let's say, if you have built a machine learning model to predict the, let's say, Boston house price, right? Uh, let's say you have built machine learning model to do a very small task. That can we can think of as a narrow AI that has a very limited ability, very narrow ability. Now, artificial general intelligence is something that is not made yet, but ChatGPT, Anthropic, or these large companies are trying to build these artificial intelligences. Like they are trying to build these AGI. AGI is basically artificial general intelligence is something that you can think as just like humans, right? We humans have capability not just to be expertise in one field, but also in multiple fields. We can drive the car, we can cook the food, we can talk to someone, we can give them answers. We just can do a lot of different things. Maybe we can singers can write songs, can sing them very well, compose music, write stories. But today, one AI cannot do all of those things. There is an AI, let's say Tesla has self-driving car, that's a different AI. We have Chat GPT that does a lot of different writing works, that is a totally different thing, right? So, like one AI is not capable of doing all of those things, but that is what the definition of artificial general intelligence. When you have a general level of intelligence, as we human do, then we can call it a AGI. The next comes the super AI. Super AI you can think of as in the movies like Terminator or Age of Ultron, where AIs can start creating themselves, or they can literally do anything that you can't even imagine, right? AI has like unimaginable control. then we can think of it. It's like super AI, but here we were talking about AI, ML, and DL. See, ML is basically a data-driven AI we can think of. Machine learning is a data-driven AI where we try to learn the machine with the help of the data that we pass into, right? Now, machine learning you can think of as a black box analogy, right? Machine learning has three types of it. Machine learning you can think of as a black box analogy. Now, how do we learn? We machine learns based on examples, right? We give a lot of different examples. So, for example, here I'm giving an image of banana. I'm telling that this is banana. I'm giving an image of an apple. I'm telling that this is an apple. And I will give various varieties of bananas, green bananas, yellow bananas, small, large, cut piece, small piece, and all that. Similarly, green apple, red apples, a lot of different types of apples I'll give them. Small, large apples with different background colors, apple with leaves, apples on the fruits, apple on the tree, apple cut on the plate, all the different images. And then machine is going to learn that, machine is going to understand that if you have coded that really well. Now, that is an example of how machine learns. That is exactly how human also learns, right? That is the data-driven AI. Now, you can extract the features, you can build the data machine learning models, such as, you have regression tasks, ML tasks, and classification tasks. I'll come to that. Before that, let's understand what's the difference between ML and DL. DL, basically, ML, you can think of as using statistics, mathematics, and a lot of different other tools and techniques. But when you talk about deep learning is a totally different techniques. Deep learning intend to mimic how exactly human brain works. So human brain are made of a lot of different, I would say, neurons. Similarly, we try to build artificial neurons as a software, and we try to make them learn. We try to feed the data into that, and we try to make them learn how exactly human brain does. Right? We try to make them process and learn the information exactly human brain does. That is deep learning. The difference between ML and DL is that when you're using statistical modeling, when you're using mathematics a lot of the different ways, then that is deep learning, but sorry, that is ML. But when you try to mimic exactly how human brains are made, creating artificial neurons instead of biological neurons and making them a shape exactly as human are, right? Then you can achieve a lot of different stuff. See, today's chat GPT and a lot of different AI that you see, they are built on this deep learning architecture itself. So deep learning has gone through phase from very simple neural networks to a very complex neural network. Simple neural networks can do a very simple task, right? And a complex neural network can do a very complex task. Human, as usual, they have evolved and they have generated a very complex neural network in their mind. If you talk about very simple, let's say fishes or parrots or a very simple species, they have simple neurons. That is why they cannot process a lot of different information. They cannot learn, they cannot speak, they cannot maybe solve a mathematical problem, right? But humans can because their neurons are complex. They have a lot of different things, and scientists are studying and scientists are actually processing these information how to mimic the human brain exactly. Humans are smartest ones in the planet on the planet, right? So that's the difference between ML and DL. Now, DL also require a lot of different mathematics, vector calculus, linear algebra, but that is to implement how exactly humans are, the brain is made. Yeah. Do anybody have any question in between? Please feel free to like put in the chat section, or you can unmute yourself if you are in a clear environment. I will be happy to answer your questions. No issues. Now, let's talk about all the different types of machine learning. We have um, two types, like supervised learning, unsupervised learning, and reinforcement. Supervised learning has two types. Supervised learning, basically, that means that we have a label data, right? For example, I'm showing an apple and also telling that this is an apple. So there is an association. Association with the apple and association with the name, right? For example, I have a sheep, right? I have a sheep. I'm telling that this is a sheep. That means the code is going to associate this picture, the feature from this picture, with that label called sheep. Similarly, let's say I have a camel, right? I have a camel. I will feed this data into the model, this picture maybe. The features of this camel is going to get feeded into the model, and along with that, a name is going to be attached with that. That's the label, a camel, right? Let's say while training itself, I give it a name, let's say elephant. The picture will be associated with the elephant. Whenever model sees this picture, they will call it an elephant, not a camel. So remember that the label should be correct. Like label should be exactly how humans follow them. Otherwise, the model cannot be able to handle that. For example, since the childhood, if you tell a person every time you see a camel, you tell them that's an elephant, they are going to say a camel and elephant. Exactly. Similarly, machine learning works, right? Now, this is an example. Coming back to our labeled data, I mean, that is called the label, right? Along with the data, there will be a label associated. That is why it's called supervised learning. Now, every time, let's say I have a camel and a sheep classifier, I will give a picture of either of these, either camel or let's say, sorry, either sheep, oh my bad, either camel or a sheep, right? And then I will ask the model, what is this? The model is going to say either camel or the sheep. But while training itself, let's say I passed an image of a camel, but the model said that this is a sheep. Then while training, I can give it, something called correction, error correction, right? That's called back propagation. Then I can tell that no, this is not a sheep, this is a camel. And actually, the label name helps us into the classification later on, right? The label that we are passing helps us. Why? I mean, how? Because let's say I'm saying this camel as a sheep. So the error will become high. In the error, we will utilize the name of the label of the data, right? And that is how model will understand what it is doing right, what it is doing wrong, right? And in that way, it is going to learn how to classify a camel and a sheep. Very simple. That is a classification task. Now, the label can also be numerical. For example, my salary and my experience. Let's say, based on the experiences, salary can increase. Salary is a numerical number. Now, if I'm calling that a label, then that becomes a regression task. If you are going to predict numerical values, then that is called regression task. That is also a label, but that's a numerical label. Then that will be called as a regression task. Now, if you are going to predict continuous numerical value, that is a regression. If you are going to predict categories such as there are two categories here, like I am just saying two categories, but there are a lot of categories. If I'm just passing either sheep or a camel, then that becomes binary category. That becomes there's two categories. Then this is classification task. The categories can be even 100 categories or millions of categories can also be there, but that still is, you know, category. Now, there are some ML models that we do with the help of unlabeled data. Like I have the images of camels and sheep, but I don't have a label along with them. Then maybe instead of doing the classification, I will just categorize them in different groups. Example, male, female categories. And yes, Rhea, that is a very good example, right? Male, females are categories. But if you talk about age is not a category, it's a continuous numerical value. Then that will be if you're predicting, let's say if given an image, if you're predicting if the person is male or female, then that is a classification. If you're predicting the person's age, then that is a regression, my friend. Right? So this is an example. Now I'm gonna ask you guys a couple of questions. Tell me if that is a classification or a regression. Let's say I am building a self-driving car, right? Now I am deciding whether to go straight, to go left, or to go right. There are three different ways to go. I'm building a model that will decide to go straight, to go left, or to go right. Now tell me, what is this? Is it a classification or is it a regression? Predicting straight, left, and right. Is it a classification or regression? All you have to think about, it is a category or it is continuous numerical value. Take says that is a regression. Take Baba, can you tell me, is it a continuous numerical value? Left, right, and straight. Is it a continuous numerical value? It is not. It is just three categories. Out of all the different categories, like I'm just saying either left or right or you know straight. So that is your three different categories, and that we can think of as a classification. That's classes, the different categories. If I'm saying that, let's say not predicting the left, right, and forward, I'm just saying the degree of steering from 0 to 90 or 0 to 180 or whatever. I am predicting the degree of steering, like how much you are steering your car, or let's say I'm building the self-driving car, right? So how much should it steer? By what degree? When I'm talking about degree, Vishwanath Nancy says it's a regression, and that's a correct answer. Because here I'm not predicting left, right, or straight. Here I am predicting the degree of turn. Now it is regression. That is good. You understood, right? Now this is regression because we are predicting the continuous numerical value. We are not predicting the classes. That's great. Now let's go back to unsupervised learning. There are some problems where we don't have labeling, right? For example, there is an animal kingdom and there is a plant kingdom. I'm giving a picture of an animal, no matter if it is camel or if it is sheep and all of that, that should go into one basket. The plant should go into the other basket. As well, as long as I am giving them a name associated with that. Let's say I'm passing the image of camel, saying that this is an animal, passing an image of a sheep, saying that this is an animal, passing an image of myself and saying that this is an animal. Yes, obviously we do come into an animal kingdom. Don't worry about it. So that is an example of again classification. If there is a label associated with that, that will be a classification. If there is no label, then that will become an unsupervised learning. And within unsupervised learning, we do we do not have the label in the data, and we do something called clustering. Clustering is nothing but grouping them based on the similarity and dissimilarity, right? For example, I gave you a bunch of fruits and ask you to separate them. I have not given you the name of the fruits. Maybe you haven't seen those fruits in your entire life. And I ask you to separate them. How will you do that? Can anyone tell me? Let's say there is a basket of different kinds of fruit and you don't know their names. Names means you don't have the label. And I ask you to separate them. I give you three different baskets, empty basket, and I ask you to take and separate those among these three. How would you do that? Mine says color, shape, size. Sheikh Baba says yes, size, shape. And this is actually good thing. You guys are understanding it, right? This is my friend we call clustering. So based on similarity and dissimilarity, if a fruit is has the same color, maybe you'll pick that and keep in the same basket. If their shape, their sizes are similar, maybe you'll pick them and keep in the same basket, right? So that's what we call clustering. And there is also something called reinforcement learning. Reinforcement learning is basically um, where we try to enforce the learning to the learner again. Take an example of a kid, a small person, um, who is trying to a small kid who is trying to learn how to walk, right? Now, every time he walks, You give them a chocolate. Chocolate, it's a treat. If it is a good thing, it's a reward for them. Every time they fell down, they feel pain. Pain is a penalty. So, if you create a good reward and penalty policy and ask the agent, we call that learning agent, ask the agent to do the same thing again and again and again and again, millions of times. Like humans are smart, they don't need to do the anything millions of times to actually be better in that. But machines do require machine required to run anything millions of times in order to understand that and process that, right? So that is called reinforcement learning. So eventually, if you have good reward and penalty policy, the learning agent will learn how to maximize the reward and decrease the penalty, right? This is how we do the reinforcement. That's why we call reinforcement learning. We are enforcing the agent to increase the reward and decrease the penalty. That's very simple thing. As simple as it sounds, the complexity and the coding is very very complex. Right? It's basically see, reinforcement learning is nothing but learning by doing something. You do something, you realize there is a mistake, you correct that again in the next iteration. That is what called reinforcement learning. Now, um, there are a lot of different examples over here. Here's here and here. Yeah. Now let's talk about what's the difference between data science. What's the difference between data science and data analysis? The only difference between data science and data analysis is basically the difference of machine learning or difference of AI. If you add artificial intelligence in your analysis, then that becomes data science. Data analysis, you have statistical knowledge, you have mathematical knowledge. You are doing a lot of different things, a lot of different analysis, presenting the KPIs, scores, analysis, and all of the different things. But if you add an AI layer on top of that, that becomes AI. So far, you told these are how can we collaborate. Yes, that's what I'm coming into that. Now that you understood AI, it's not AI is not something magical. There are different parts of AI. Now that you have understood AI, let's understand how can you collaborate them, how can you utilize that. Yes, Shreya says reinforcement learning snake games by playing on the mobile points, gaining the kind of rewards. Yes, exactly. Now let's come back to our topic. Now that I've already talked about the difference between AI and data science, like data analysis and data science, it's the difference of AI. Now let's come back to our topic. Now, as I said, these are nothing but different AI techniques. Deep learning for complex tasks because that has more ability. Machine learning has supervised, unsupervised, and for segmentation or forecasting and all of that. Natural language processing is a way to analyze the text data. See, you have to understand machine learning operates on numbers. Analyzing the text data is a very crucial thing. And that is why we have a separate department for that. That's called natural language processing. There are different other tools and techniques and other use cases in there, right? In the natural language processing. Now, how can you automate your data presentation, right? For example, data preparation. Sorry. Let's say before AI, if you are focusing on 80%, see, I must tell you one thing. Me, I have more than 6 years of experience working in the corporate. And so far, I have learned that machine learning creating machine learning model is not the toughest job. Building the data for it, your 70 to 80% of the time is going to go into the data processing, data preparation for the machine learning model. But with the help of AI, you can ask them to write the code and you can ask them to transform the data for machine learnable modeling. Now, with AI, you can do that. You can automate most of the works with the AI. You can ask them to write the code. You just have to plug and play. You just have to plug the data. Now the AI is going to give you the transformed results. Even you can create, let's say, you might have learned about the Power BI dashboards and Tableau dashboards. You can also create the dashboards with the help of AI, right? You have a lot of benefits of that. You can have time saving. You can have error elimination. There's very less chances of errors if you're using artificial intelligence. You can have quality improvements, and you can also scale the same thing to multiple different people. Now you can also do AI analytics in advanced versions, like such as predictive analytics. You can use different machine learning models to do one predictions and then combine them. You can do real-time forecasting, automation optimization, and all of them. These are different examples, actually, the customer churn analysis, anomaly detections, and all of this. Now, you can, as I said, I just talked about the AI powered visualization, right? Power BI has support of Copilot. You can utilize that AI to build automated visualization. If you have enterprise versions of Power BI, like if you're working professional and if you have Power BI access, you can go and check that out. You can give the prompt, you can give the input data, you can give the prompt, what all do you want? But the prompt should be clear. Uh, we at Accelerator X, we tell you how to write prompts, how to write clear prompts, how to get the maximum out of large language models, right? So if you continue to follow us, you should be able to understand how to do all of these things. Now, you can automate a chart selection. What's a good chart for what data type? How your dashboards will look dynamic. Now, how can you do the natural language analysis? Ask questions and get the answer in English language, just like talking to an expert. This is the basic, like, this is the very good thing about uh, AI powered visualization. Now, there are some, I would say, popular AI tools and platforms you must check it out. Tableau AI, Power BI AI, these I already talked about. These are the enterprise platforms. You'll not get them free, but there are some such as Data Robot. Data Robot is a data analytics tools. Alteryx is data analytics tool. They have AI in there. You can give them the data, just write a prompt, and they can give you. They can analyze the data, and they can send it to you. Like again, you must understand it's not like if you don't know the intelligence, if you don't know the analytics, you cannot do AI in here. Only if you know the analytics, then you can utilize the AI and do the work of 5 hours into maybe 5 minutes. But don't think if you don't know the AI, you can do that. Basically, you have to tell the AI what exact metric you want. Until unless you know analysis, you can't pass that. But here I'm telling you, how can you utilize AI to do these specialized analysis, right? But still, you have to learn the analysis. And we at Accelerator X will give you chances about how to start and how to do the you know analysis, how to learn the analysis. We have a full multiple months. You can go to Accelerator X XAT our website. You can search on internet. You can get that. We have data analytics program. We have business intelligence program. Right? You can go ahead and check them out. Now, coming back to the topic, there are some cloud AI services as well. We have Google Cloud. We have Amazon SageMaker. We have Microsoft Azure. But if you are trying to learn these, maybe you can start from Microsoft Azure, and you can actually go and learn with the help of a lot of different courses. But if you go into if you are in the industry, maybe you can switch. You can ask your um, employer to give you the access, and you can learn them. You can learn about those things. Now, how can you get started? Now, first of all, you have to understand what's your current phase, right? Where are you at? It's like judging your own water. So where are you at? Just try to assess that. Try to write down the skills that you have. Try to write down what all these skills you need, and all of that. Just try to assess where are you at. And then you have to just write down where you want to go, right? Where are you at, where you want to go, and that will tell you what path you have to take, right? Then you can do some courses, do some projects, right? For module developments, data preparations, trainings, and all that. And then you can scale and optimize with the help of artificial intelligence. Once you understand that, you can go and utilize the AI to do the work that maybe um, people used to do in days. Maybe you can do it in hours or in minutes. That's the difference. Now, apart from that, you can also do you know hands-on demonstrations and all that. You can automate insights, predictive modeling. Let me just show you a bunch of other analysis actually that will help you how to get started with that. So, for example, I'll go and tell you about the how to analyze the data in Excel. In Sheets, actually, Sheets has that AI. So, any tool, even Excel, the current Excel, the enterprise version of the Excel has AI in there, right? Let's say I have this data, right? Now here there is an option that says analyze this data. There is an option that says summarize this data. Now, see, this is basically Gemini AI, Google Gemini AI is basically doing this. Now, if I click it here, it is doing all those things and it is going to analyze it. It is going to refer from this A1 to H column and 101 row. From here to here, it is going to analyze all of that. Now here, there are some plots, there is some KPIs, key takeaways 2, key takeaways 3, and a lot of different things. If you want to say exactly, write a prompt over here. There are some charts and plots. You can go and do that on your own. Just try to get some data on the internet, put that on the Google Sheets, and you will get an option to actually chat with the data. Right? If you ask the questions over here, now let's say give me a plot to plot. Let's say give me a bar plot of product sold. Okay, let's say I have given that. It is referring that. Now it is creating bar plot to visualize the number of products sold. It might be writing some code there, but now you can see 60 around bags has been sold, charger has been sold more than 60, and this is that. You see, this is how you do the analysis, right? This is how you do the analysis. Now, you can also do that with the help of code as well. There's a similar Google collaborative platform, Google collab.research.google.com. I'll send this link to you. You guys can also check this out. And this is here, you can actually utilize this. Let me show you. Um, Sorry, I'm not able to hear you clearly. Maybe you can write the question in the chat section. I'll see that. Okay. Now you see, let's try to analyze the data, right? What you can do, you can add the data over here, and you can ask the AI to you can ask the AI to actually write the code, and it will be able to analyze the data for you, right? So you can connect over here, connect to the resource. Now there is a Gemini, right? You can ask Gemini to write the code. You can see how do I filter from pandas data frame? How can I create a plot in Collab? Show me the list of publicly available data sets. Let's see. Let's do that. Now I'm asking is to use one of the data set, encode, and analyze it. Now I'm just giving it a vague prompt. You see here it is giving me the code. Now let's copy this, paste it somewhere here, create a new code shell. I'm pasting it here and running it. See, this is the iris data. I'm not sure how many of you know, but here is a small analysis. First five rows, there's the number of columns, descriptive statistics, the count, mean, standard deviation, minimum value, 25th percentile, 5th percentile, and all. There are a number of values. Like all species has how many values. Now, if I ask it, give me a um, not bar graph, scatter plot of sepal length and sepal width. Let's do this and see what do we get now. We see we have got a code. We can copy this here. We can ingest it over here. We can also click this here. Add code to the cell. It will add that. See, run it, and you have got this scatter plot. So you can actually do all of these analysis, right? This is how you do it. Now the same thing is available in Excel. If you have paid versions of that, you have enterprise versions of that. The same analysis, a lot of different other analysis available in Power BI and other different tools that we just talked about. Right? If you want, you can take a screenshot of um, this, right, and try to understand this. Now that is it. I would say thank you so much, everyone, for listening me really carefully. I just tried to understand you guys like since you guys were mainly the student, I started with what is AI and then letting you know how can you utilize the artificial intelligence in your analysis workflow. So that's it, I would say. If you guys have any question on this, you can let me know. I will be happy to answer that. Thank you so much, everyone. If you guys have any question, do let me know. I'll be happy to answer that. Either you can unmute yourself or wait a sec. Either you can unmute yourself or you can put the chat, put the question in the chat section. Um, so I am not currently logged in with my work laptop. This is my personal laptop, and that too, it's a Mac system. So I cannot directly show you, but you will see there is a small co-pilot icon in your Power BI if you have. You can go there, and then you can see, there is an option, right? You can see somewhere on the YouTube, you will find an option. So the Copilot option, this is where you can enable the AI in your Power BI and you can ask them, give them the prompt, give them the data, and you can actually show them, like, you can create the plots based on that. Anyone else? Anyone? Yes, Rhea, that is actually only for the paid versions. To be honest, if you're working professional and you have that, you know, the enterprise versions of Power BI, then you will have that option actually. Okay, I guess that's it, guys. Thank you so much. If you guys have do not any question, then you guys can leave. If you still have any question, you can stay here and ask me. I will be happy to answer them. That's it. Thank you so much, guys. Thank you so much. I'll see you in the next one. Bye bye.